Hey everyone, welcome back. In this video, we're going to talk about your climate project, which has now been assigned. So you'll see at the bottom of the screen here and in the title of the video that this is the first video of Unit 4. So basically what we're going to do is we're going to wrap up Unit 3 after this, and then we'll go on to talking about climate in a little bit more detail in unit number 4. So this is sort of the first video of that, but I'm putting it out as early as I can. It's a bit later than I wanted to, but we did talk about this last week. But I wanted to make a recorded video so you could go back to this and hear some of the things that might not be covered in the slides, just in a little bit more detail. So this project, you guys have already been assigned the cities for it. We'll see more of this in a few minutes. So basically, in this project, what we're going to be doing is we're going to be talking about continental and maritime climates. So basically, there are lots and lots of different ways to classify the climate of a given region. And actually, there's a website that I'm going to offer that you guys can use to get your climate data for this assignment. And what you might find when you go there is that that website doesn't classify the climates of different places as continental or maritime. It classifies them by a whole bunch of different names, stuff that we haven't seen yet, and depending on how our climate unit goes, we might not see all of those names there either. So basically what we're doing, we're simplifying it down into talking about just continental and maritime climates. So we're going to talk in the coming slides about what those are, or like how to tell one apart from the other. But so basically the idea here is, if I can get my pen, the idea is that different parts of the world experience different climates. So by different parts of the world, that's not really specific. You could think of that as one city to another or one region to another, well, whatever you want. And different parts of the world experience different climates. We already know that, but the location of, for example, if we're talking about cities, since in this project you guys are going to be working with different cities, in this project you are going to be looking at the climates of different cities, and you'll see that the location of the city kind of dictates, not necessarily like in a complete, like in a perfect way, but the climate of a given city is responsible for, or is caused by its location. So, if you have North America, so we got Alaska kind of there, and then, this is a really crude drawing of North America, so don't criticize it too much, but let's say something like this, and ignoring all the islands. So suppose you've got a landmass like this. Of course, that's not perfect, but basically the idea is that a city, we already know that a city here in Mexico is going to experience a different climate than a city way up here in northern Canada. So like if I were to draw in the borders, Canada and the US, their border is like that, and the US and Mexico, their borders like that, and then we also got Alaska over here. So if you weren't seeing North America before, hopefully you now have a bit of a clearer picture of it. And so I think you could easily tell that a city up here in Canada is going to have a different climate than a city down here in Mexico. But what people might not realize quite as easily in general is that a city, let's do this in blue, is that a city here and a city here will experience different climates. One's not really farther north than the other, they're both kind of on the same line of latitude. But the difference is one of them is on the coast. This one over here is on the coast. And what that translates into is a maritime climate. So basically we're focusing on the climate differences between whether you're way deep inside a continent or way out near the coast. So that's what we're going to be talking about in this project. So we're classifying the climates of cities, different cities, into one of two categories, either a continental climate or a maritime climate. So your job in this project is going to be to look up the climate data for 10 different cities which you have been assigned. And what you should do is you should include these things for each city. So for each city, you should include a climate graph. I'll show you what that looks like in the later slides. So you should include a climate graph for each of the cities. So your presentation, whether it's a PowerPoint or like a like on a Bristol board or something, that has to include 10 different climate graphs. I don't want to see one climate graph. One climate graph for each city is what you're responsible for. So that should be 10 climate graphs in total. And then based on the climate graph, you should decide whether each city experiences a continental or a maritime climate. So we're going to talk in the coming slides about the differences between continental and maritime climates, and basically how you can look at a climate graph and tell the two apart. And this one I haven't listed as a bonus. I'll say that if you're making it on a poster, so like if you're hand making this thing on, and you know, you're drawing in these things and coloring everything in, then maybe a map is a bit too much. But if you feel like printing stuff off, then you could do that. If you're doing it on the computer, this is absolutely mandatory that you include. If you're doing it on paper, like I said, if you don't have a way to print it out, then maybe then we can talk on like a case-to-case basis about whether or not it's reasonable to ask you to include a map or a picture of where that city is. It doesn't have to be detailed at all. It's basically something like this, but maybe slightly better, like slightly better drawn. And then just indicating, you know, if you're talking about Los Angeles, you should know that it's more towards the coast than it is over here, right? Like that's kind of the difference that we care about, because if you can include that map and you know that the city's location determines whether it has a continental or a maritime climate, then you could just look at the map and have a rough idea of what its climate graph should look like. And so for that, actually, that's a bonus mark if you include in your presentation or on your poster somewhere. Well, okay, so on your poster you should include whether each city has a continental or maritime climate. When you're presenting your poster or presentation to the class, if you explain ahead of time that this is where the city is located and therefore I think its climate should be this, and then you show the climate graph and you say, based on the climate graph, its climate is this. If you explain based on the location whether you think a city has a continental or a maritime climate solely based on its location on the map, that's a bonus mark. So it's a really, really easy bonus mark to get, and there are 10 bonus marks available because it'll be 1 mark for each city. So you can have that, you can have 10 bonus marks there. Additionally, you can have you can get bonus marks if you show how the climate of a city. I've said each city, but you'll get the bonus marks for each city that you do this for. So for a given city, let's say somebody's studying London, England, then if you also include a climate graph, or sorry, not a climate graph, some sort of graph or some sort of table of information that shows how the temperature and precipitation has changed over the course of many, many years, many, many decades, preferably, then you can bring climate change into the discussion. You know, has it gotten hotter? Does it rain or snow more or less? Oh, that's something that's worth clarifying. If you haven't heard this word before, precipitation is just stuff falling from the clouds. So rain, snow, that's kind of basically it. So precipitation is just how much it rains or snows in a given area. That's what you're going to be looking at on these climate graphs. But basically, yeah, so 2 bonus marks available for each of the 10 cities. One for whether the climate has a continental or maritime climate based just on its location, and that's something that you would have to explain in your presentation. And the other bonus mark is if you talk about climate change. Now, in this presentation, I'm going to give you a few links that you can use to obtain your climate data just for the climate graphs. But if you want stuff for the climate change data, that's going to be something you have to look up yourself. Okay? Okay, so how do you know by looking at a climate graph if it's got a continental climate or a maritime climate? So I found this while I was doing some reading about this online, and I don't know if this is necessarily the most precise method that you could use to determine the climate, but it's good enough for our purposes. Um, so basically what happens with the climate graph is you've got your axes like this. I'm going to show you a climate graph for reals on the next slide, or maybe the slide. I think this is the next slide. And basically you've got the months of the year going across the bottom. So we've got January over here, you know, June, July, and December all the way over there. And then on the axis, on the vertical axis, it's slightly confusing. Basically there's a series of numbers in red, which uh, which is representative of the temperature. And then there's a series of numbers in blue, a different set of numbers, and that's talking about the precipitation. And so your climate graph might look something like this. If it's really cold in January, and then it gets really, really hot in June, and then it gets colder again. That was a little, that's not kind of the right shape, but maybe something like this, and then it's warm for a couple months, and then it gets colder again and goes back down like that. So the red line is the temperature, and so if you're trying to read the temperature, you'd use the red numbers on the scale. And then for precipitation, they'll put these bars in blue, so you'll have like a little bit of rain in January, and then maybe no rain in February, or like almost no rain, and then like maybe, whoa, and then maybe lots of rain. Whoops. Maybe lots of rain in March, for example, and so on. And so you'll have these different bars for the precipitation. Um, and so you can read off how much it's rained or snowed by just sort of kind of going across and looking at the blue numbers on the scale, and that'll tell you how much it tends to rain or snow on average in that particular month. And you can add up all of those for this second point, which we're going to talk about in a sec. Um, and basically that's it. That's all there is to a climate graph. You'll have a line for the temperature, and you'll have these blue bars for the precipitation. So to decide if the climate in a given city is continental or maritime, you can look at these three things. So first things first, large temperature range or small temperature range. So what this means is if the difference between the absolute highest point on the temperature part of the graph and the lowest point, which is maybe right there, if this difference from top to bottom is bigger than 25 degrees Celsius or equal to 25 degrees Celsius, that's an indication of a continental climate. If it's smaller than that, then it's a maritime climate. So if you had a temperature graph that instead of the temperature graph looking like this, maybe the temperature graph only looks like this. It might be a smaller difference in temperature, right? Going from the top here to the bottom here is a much smaller gap than going from the top here to the bottom here, right? So that's how the temperature range thing works. Now you look at precipitation. If there are less than 1,000 millimeters of precipitation, you have a continental climate. So that's basically, you look at all the blue bars on the climate graph and you add up all the blue bars together. So like maybe this one says 10 millimeters of rain, and maybe this one says 1 millimeter of rain, and then this one says, 500 millimeters of rain. Then you can add up all those different things, and if the total comes out to be less than 1,000, then it's a continental climate, and if it's 1,000 millimeters of precipitation or more, then it's a maritime climate. But so what happens if you have, if you look at the temperature range and the temperature range says, oh, well, it's going to be a continental climate, and then you look at the precipitation and the precipitation says, oh no, it's going to be a maritime climate. We're also going to look at one more point, which is this one at the bottom here. If most of the precipitation tends to occur in the summer months, the climate is continental. And if most of the precipitation tends to occur in the winter months, the climate is maritime. So what happens if you don't have the same, what happens if you get that the temperature range suggests it's a continental climate, the precipitation suggests it's a maritime climate, and then most of the precipitation is in the winter, which would also suggest a maritime climate. Basically, it's a case of majority rules. If you've got two things that are pointing towards the climate being maritime, it has a maritime climate. If it's got all three things pointing towards maritime, then that's great, it's maritime. Similarly, if it's got all three things are pointing towards it being a continental climate, then it's continental. And if it has two, any two, doesn't matter which two, so it could be like this one and this one are both pointing towards it having a continental climate, or it could be this one and this one, or it could be this one and this one, all pointing towards a continental climate. So it doesn't matter which two points, but as long as there are 2 points that are pointing towards it being a continental climate, then it has a continental climate. So that's what I've listed down here as continental qualities. So you could say that's by no means an official term. That's just what I'm calling it. So if it has a large temperature range, you could say that's a continental quality. And then if you can find one more continental quality from these two things, then it has a continental climate. And if you can't, then it has a maritime climate, because that if you can't find any more continental qualities, that means both of these are maritime, which means that you have 2 or 3 maritime qualities. So hopefully I haven't confused you more. If you have any questions, please feel free to ask me. So here we can look at an example. This is from Santo Domingo, and you can see the climate graph, the way it's going to look when you guys are doing your research for the 10 cities. So the website that I'm going to show you, this is from the website I'm gonna give you the link to, and you guys are going to go there and look up the climate data for the different cities by yourselves. And many of you will be studying Santo Domingo, so this is kind of a freebie for you, I guess. So what you can see here, if we look at the temperature range, this first point up here, if we're looking at the temperature range, the peak of the red graph, that's the temperature graph, the peak of that is around here, and the lowest point looks like it's probably this one. So the gap, I haven't drawn this perfectly, but the gap is about this big, right? It's not a huge gap. And if I just sort of drag those over to here, so this is the column that we want, degrees Celsius, right? Because our temperature range needs to be in degrees Celsius. And actually this should say less than 25 Celsius degrees, I think, and not 25 degrees Celsius. So sorry about that. Yeah, when you're talking about a difference in temperatures, like a range of temperatures, I believe it's supposed to, the degree sign is supposed to go after. But anyway, if we drag over the other line and it goes to about here, something like that, then just by eyeballing this, you can see that this right here is at about 23 degrees Celsius, and this is at about 27 degrees Celsius. So if this is 23 and this is 27, then you can see that the difference between these two is just a subtraction. 27 minus 23 is 4 degrees. So that's definitely less than 25 degrees. So that's a maritime quality, you could say. Now, precipitation. If you add up all these blue bars, and you don't have to do it precisely, the blue scale is over on the other side here, and we want the millimeters one. So we look at this one. And basically you add up the heights of all these blue bars. It doesn't need to be perfect. You can see that this says 50, so you could just assume this is 50, this is 50, this is 50, this is, I don't know, you could say this is 40, you could say this is about 70 because that says 75. And so you can kind of eyeball it. You can start with the biggest ones and go from there. So this is 150, so these three together is going to be 150 times 3, which is 450, plus a little bit extra. So if you're getting that your number is really, really close to 1,000, then maybe you could recount and try to be a little bit more precise. But it is difficult to get a super precise number. So it's okay if you look at this and you say, yeah, all of these are 150 or 155 or whatever. And, you know, just kind of round to the nearest 5. So you could say that this is 125 and this is 130 and this is 135 or something, for the different bars here. Alternatively, and I'm going to show you this on the next slide, there is a data table containing information about the temperature and about the precipitation. So if you're not sure about the precipitation numbers, I believe you could just read them off that table as well. But anyway, for the precipitation, if you add up all of these, it should come out to more than 1,000 millimeters. So that's another maritime quality. So we already have 2 maritime qualities, which suggests that Santo Domingo has a maritime climate. But the last point, just for the sake of completeness, seasonal precipitation, more in the summer is what we can see here, right? If the summer, this is month number 5 is May, month number 9 is September. If you say that your summer months fall roughly in there, most of the precipitation seems to fall in these few months as compared to, you know, there's hardly any in January, February, and March compared to, you know, August, September, October. So, so from that you can get that there's more in the summer. Now, a word of warning. What you need to be careful about is whether your city that you're looking at is in the northern hemisphere or the southern hemisphere, because that changes which months are summer. So that means 2 things. One, when you're looking at the seasonal precipitation, the summer months for the northern hemisphere would be these ones here. So, you know, roughly these ones here. This is May to September. But if you're looking at something in the southern hemisphere, in the, you know, southern Argentina or South Africa or something, then your summer months over there would be, you know, maybe like November to February or November to March or something. So you need to think about that. You need to think about that when you're looking at your climate graphs to check whether there's more precipitation in the summer or the winter. You need to look up where your city is to be able to tell if it's in the northern or the southern hemisphere. Now, if you're talking about a city that's really close to the equator, then it won't make much of a difference either way, because at the equator you don't really experience seasons all that much. But chances are that there won't be a huge variation in the seasonal precipitation in that case. Now, that could be wrong, and you might run into trouble, and if you do, let me know. But basically, these are the things that you have to look at. You look at the temperature range, you look at how much it rains or snows, you look at when it rains or snows, and you have to keep track of what counts as the summer months and what counts as the winter months. And so basically you'll see that either the precipitation tends to go like this, you know, more in the summer, or like this, more in the winter. And you might have some places that it just rains a lot all the time and there isn't really a big change. In that case, you know, this point just isn't useful to you at all, because it's really, really hard to tell whether it rains or snows more in the summer or winter. But you do need to be careful about the northern hemisphere, southern hemisphere thing, because if you're looking at the temperature part of the graph, then in the northern hemisphere, the hottest months are in the middle of the year, the June, July, August. So it'll look like this. But in the southern hemisphere, those are the coldest months. So the temperature graph will look like this. So don't be thrown off if the temperature graph looks kind of upside down. That just means you're in the southern hemisphere. And it's a good indicator that you need to be careful of what you count as the summer months, is if your temperature part of your graph looks like this one here. So like I said, when you go to the website, this is the website right here for you. I will hopefully remember to put a link in the description when I'm uploading this video. But basically go to climatedata.org and you can search for the different cities right on that website. And then when you click on that city, you'll see the climate graph like what we just saw for Santo Domingo. But if you scroll down, you'll also see a table like this one. So this is also for Santo Domingo. You can see the average temperature, which I think is what they use to plot the red temperature line on the graph. Minimum and maximum you don't really need. And then here is precipitation. So you could read off the precipitation numbers from here and add them together. And if it comes out to be more than 1,000, then you've got yourself a maritime climate. And then we don't really worry about the humidity and the rainy days. So you don't need those. You don't need the min and max temperature. You do need the average temperature and the precipitation. You don't have to use the table. You're more than welcome to just use the graphs. But if you're finding that it's hard to read, then you can use the tables that are right on the exact same web page. You just got to scroll down a little bit. As for maps, you could get the map by taking a screenshot from Google Maps, or you could go to worldatlas.com, and I will hopefully remember to put these links in the description as well. And if for whatever reason, maybe it's not that the graph is hard to read, but you want to build it yourself based on the data, then you can take this data table, look at the average temperature row, look at the precipitation row, and build the climate graph yourself. And if you really want to check your understanding, you can use the data, you plot, okay, this is January, and this is February, and this is March, and then, you go through the whole year, and you get some, whatever, for your temperature. And then you also plot the bars for your precipitation, and then you can compare it to the graph that's provided on the website, and you can see if you figured out how to build this properly. So that would be tricky because you'd have to think about, okay, well, what numbers do I put on the axis and stuff, and it can get complicated, but if you want to do that, there's nothing stopping you, but you could just steal the graphs from that website for the purposes of our little presentations to one another. And lastly, I don't mean for this to get much longer than it already is. Basically, you guys have, so right now at the time of recording, we're nearing the end of March. So you guys have like a month and a half-ish to finish researching your 10 cities, building your poster or your PowerPoint, getting the climate data, getting the climate graphs onto the poster or into the PowerPoint, deciding whether each city has a continental or maritime climate, if you want to do the bonus marks, all that stuff. And so basically you have to do that for all 10 cities, and you can start thinking right now about how you want to arrange your poster or your presentation. You should include a map, you should include a climate graph, and you should tell the people watching that the city either has a continental or a maritime climate. So you could do that by, if you're doing it on PowerPoint, you could make the entire background one color for continental and the entire background another color for maritime. As long as it's still easy to read stuff on the screen, that's totally an option. That maybe you write down the whether if a city has a maritime climate, maybe you color it blue. You color the name of the city blue or the background blue. So that way, when you're going through your presentation, you can say, here's the climate graph, here's the seasonal precipitation, here's how much it rains, here's the temperature range, and therefore I think it has a maritime climate, and the slide is blue, and it makes a lot of sense. So you need something, you need to also tell each other when you're giving the presentation specifically that this city has a continental climate. It's not supposed to be something that the reader or the viewer has to stare at to try and figure out themselves. When you're presenting, you should be really clear about that, that you're saying London has a climate. And so try to approach it that way. We can always talk about this more in our Zoom classes. If you have any questions, feel free to email me, get in touch on the Google Classroom or, Instagram, whatever. But hopefully this has given you guys a nice, thorough introduction to what is expected of you and how to go about finding the information you need for your climate project. So without further ado, I will let you guys get started. And if there are no questions, then I will see you all in the next video. Have a good one.